morning, good afternoon, or good evening, whatever the case may be. In this video, we're going to do a little topic here, completing the square. We've been doing a lot of factoring lately. We're not going to do the quadratic formula, but this is what leads to it, completing the square. And we will see this pop up later in the year here in pre-calc. And if you take calc next year, complete the square comes in handy a couple times. And the book says here, how do we solve an equation in this form? A times x squared plus b times x plus or minus some constant c equal to 0. If the trinomial ax squared plus bx plus c cannot be factored, all the other methods that we've seen in the other videos, what if we run into one that we cannot factor by those methods? We cannot use the zero product principle in such a case. However, we can convert the equation into an equivalent equation that can be solved using the square root property, where we isolate the squared term and root both sides. This is accomplished by completing the square. And here's how the book introduces it. If x squared plus bx, notice there's a 1, an implied 1 in front of that x squared. If x squared plus bx is a binomial, and then if we add this b divided by 2, half a b, quantity squared, which is the square of half the coefficient of x. So this b value right here, we divide it by 2 and square it. If we were to add that, right here, we could factor it into x plus b over 2 quantity squared. And then if we have that equal to some other number over here, once the squared term is isolated, we can square root both sides to solve the problem. So here we go. Here, it's not actually completing the square. It's kind of a baby step. It just says here what term should be added to each binomial so that it becomes a perfect square trinomial. So, here we've got our ax squared plus bx. So we look at this number here in front of the x, and we take that number, cut it in half, and square it. So I'm going to cut 8 in half, that's 4, and then I'm going to square it. So if we added a 16 there, we could rewrite this as x plus 4, that's supposed to be a 4, quantity squared. Now it's nice when your b value here in front of x is even, so it's nice and easy to cut in half. But here in this second one, x squared minus 7x, it's not quite so simple because this is an odd number. So what we would have to do is cut that number in half, so that would be 7 halves, and then square it. So I'm going to square the numerator and denominator separately. Numerator squared would be 49. Oops, 49. Denominator squared would be 4. And then again, we could factor that into x minus 7 halves quantity squared. Now, in letter C, we already have our b value is a fraction. So just a little side note here, if we have a fraction, I'm just going to use letters to keep it real abstract, a divided by b, and I want to cut this fraction in half. You got two options. You can either double the denominator, multiply that denominator by 2, that'll cut the fraction in half, or you could cut the numerator in half. And that's the strategy if the numerator is an even number. Let me try one here like 4/7. If you want to cut 4/7 in half, because the numerator is an even number, you could just cut the numerator in half and make it 2/7. Or the alternate method would be to double the denominator. I'll leave the numerator alone and I double that denominator to a 14. Now notice if we reduce this, divide by 2 in the numerator and denominator, you get the same answer either way. So to cut a fraction in half, either cut the numerator in half if it's even, or you can double the denominator. So for this one, our numerator is an odd number, so let's just double that denominator. If we cut that fraction in half, it'll be 3/10. And then remember to make this a perfect squared trinomial, we would add that quantity squared to each side. So square the numerator into a 9, square the denominator to 100. So if this was our quadratic equation, we could rewrite it as x plus 3/10 quantity squared. Okay, now let's actually do a complete. And notice here, I did steal a couple things from different books here. This is a green example 3 from one book. This is a different book here, example 3. But this is a real good example of a completing the square. The leading coefficient is already a 1. So let me just rewrite it here. X squared plus 2x. Oops, I forgot my x. Now what we want to do is factor this, but we can't come up with the factors of 6, -6 that are going to add up to 2. So we want to try this with complete the square. Now what I want to do, it's this 6 that's messing us up. So let's move that 6 over to the other side of equals by adding 6 to both sides. And I'm going to leave a little gap in here, so now it's equal to +6. Now, I've set it up this way in my class before, and a lot of students have seen it kind of helps to see it like this. We want to come up with a perfectly squared binomial. And so what we need is some magic number here that's going to make it happen. So an easy way to come up with this binomial is just bring this down. Don't bring the squared with it, just the x. Bring down this side the plus, and then take this number, just cut it in half. Half of 2 is 1. But when we are foiling this out, we're going to have to square it. Our last term times our last term, 1 times 1 is +1. So if we're going to add 1 here to this left side, we're going to have to add 1 over here to make everything fair. So now this 6 plus 1 is equal to 7. And now we've got x plus 1 quantity squared is equal to 7. And now we can actually solve that. Ooh, where's my eraser? Get this out of there. Okay, so now the directions do say solve. So to actually solve this, again, we're going to square root the left side, and we're going to have x plus 1. And we're going to square root the 7 over here. Now don't forget, when we're rooting both sides like this, we do want to count for the positive and the negative root, so there's a plus minus square root of 7. And then just to get x all by itself, we're going to have x equals, subtract 1 from both sides. So now this will be a -1 plus or minus the root of 7. Remember, for these quadratics, if it's squared, it should have 2 solutions. Here we have a positive and a -1. So a -1 plus the root is one solution, and then the -1 minus the root is another solution. So again, a good example there of a leading coefficient of 1 for complete the square. I think I got another example. Yeah, here's from the other book, the green one. I like this one a little bit better because when you cut this one in half, you get a 1, and then 1 squared is 1. Here we'll see this take a little different turn, but it's not that different from the last one. So x minus 6, x plus 4. I'm going to keep my x squared minus 6x. I'm going to leave a little gap in there. And we're going to get rid of that plus 4, subtract from both sides. Now over here it's a -4. And then I want to say down here I'm going to have some perfectly squared binomial. So I'm going to bring down the variable x. I'll bring down the minus sign. And then I'm going to cut this 6 in half. So half of 6 is 3. Now think, if we were foiling this out, we would foil that out and have a last term times a last term. -3 times -3 is +9. So I'm going to add 9 here to the left of equals. I got to keep it fair. I'm going to add 9 on the other side of equals. So over here, -4 plus 9 is +5. All right, now we've got the squared term isolated. We can root this side. So we're just left with the x minus 3. And when we square root over here, it's not a perfect square, so we'll just leave it as radical 5. Don't forget the plus and minus signs for the 2 solutions. And again, to get x alone, we're going to add 3 to both sides. So now it's 3 plus a root of 5 and 3 minus a root of 5 for our 2 solutions. Okay, I think here, yeah, practice for you. So this is like the first example we saw. You're just coming up with what number you would add to this to make it a perfect square trinomial. And then here's one to try for completing the square, leading coefficient 1. So pause the video and try the problems and then start it back up. All right, for the first one, remember, take this b value. We're going to cut in half to a 3, but then we would have to square that when we bring it back. So that would be a +9. So then we could rewrite that. Then they really didn't ask us to in the directions, but I'm just having so much fun. X plus 3, quantity squared. Letter B, they gave us an odd number there, x squared minus 5x. So again, we'd take that b value and cut it in half, 5 halves. And then when we add it up here, we're going to square the numerator to a 25. That's a terrible 5, but you get the idea. Square the denominator to a 4, 25 fourths. Now here for this one, our b value is already a fraction. Our numerator is an even number, so to cut that in half, we could just half the numerator. Half of 2/3 is 1/3. But remember, to turn this into a perfectly squared trinomial, we're going to square the numerator and we're going to square the denominator. And again, just because it's fun, then that way we could make this into an x plus 1/3 quantity squared. It became a perfectly squared trinomial. And now for the real one, checkpoint 4 here, complete the square and find the solutions. Whoa. So the negative one is what's given us trouble. We'll move it to the other side where it becomes a positive 1. And then we figure out what our binomial is going to be. Bring down the x and the plus. Half of that b value there is going to be 2. But remember, when we bring it down here, we cut it in half. When we bounce back up, we square it. 2 times 2 is 4. So I'm going to add 4 to the left. I'm going to add 4 to the right. And then that turns into a 5. We're at the point, take the square root of both sides. X plus 2 is equal to the positive or negative root of 5, and bring over the 2 to get the x alone, and it becomes a negative 2. Negative 2 plus and minus a root of 5. All right, completing the square. Now here we'll kick it up a notch. The leading coefficient is not 1. We do need a 1 in front of that x squared for this method to work, and this one isn't too bad. So what we're going to do is divide each of these by 2. And luckily our middle term does turn out to be an even number in this next step. So here the 2's divide out, we get an x squared plus 8x over 2 is 4x. And then right here it's going to be a plus 3/2 equal to 0. Okay, well, let's get that constant out of the way. Let's move it to the other side. When it jumps over, it will change to a negative 3/2. And then we have over here our x squared plus 4x, and I'm going to leave a little gap in there. So coming down underneath, we do need a binomial that's perfectly squared. Bring down the x and the plus, cut that 4 in half. Half of 4 is 2. And when we bounce back up, remember when we bring it down here, we cut it in half. Bounce back up here, we're going to square it. 2 squared is 4. So over here, we're also going to add a 4. But since over here we're in fraction land with denominator as a half, let's make 4 into 8/2. Same thing as 4. So negative 3/2 plus 8/2 is 5/2. And we are ready to take the root of each side. So the square root on the left will just give us the x plus 2. And over here, we'll have a big old radical 5/2. And don't forget, of course, the plus minus. Now let's move the 2 over there by subtraction. Negative 2 plus or minus. Now let's see here. Should we rationalize this? If we were to break it up, we would have a root of 5 over a root of 2. And if we multiply by the root of 2 to rationalize upstairs in the numerator, that'll be a root 10 over a positive 2. There we go. That's a little nicer. Okay, so remember, don't forget, get that the leading term to be a 1, and then figure out your other terms and go from there. I think we got another one example. Yeah, this is from the other book. Here they just had some bigger numbers, that 9x squared, I like that one. So let's see. We're going to divide each term by 9. So the 9's will cancel, just leaving the x squared minus 6/9. Let's reduce that down to 2/3. Everything's divisible by 3. So that's a 2/3 x. And then at this step, let's even move that negative 4/9 over. It's going to hop over and become a positive 4/9. So below, we will need a perfectly squared binomial. Bring down the x, bring down the minus. Here, again, we can cut the numerator in half because it's even. Half of 2/3 is 1/3. But when we bounce back up, remember down here we half it, bring it back up, we square it. 1/3 times 1/3 is 1/9. Adding a 9th to the left, we have to play fair and add a 9th to the right. So add the numerators, 5/9. I just thought this one will work out nice. This one we won't have to rationalize after this next step, which is, of course, rooting both sides. Big old square root on the left, x minus 1/3, equals, when we square root this, let's do numerator, denominator separate. plus or minus. The numerator we can't do much with, leave it a root 5. Downstairs, though, in the denominator, 9's a perfect square, so we can root that to a 3. One last step, let's get x alone. Oop, I need a little more room here. Now see, these have a common denominator. We're going to add 1/3 to both sides. So over here, we're going to have a plus 1/3. And since we have a common denominator of 3 already, let's just make it one big old 3 down there. And then up top, let's have our 1 plus minus root of 5. 1 plus or minus the radical. And that looks a lot like an answer that we'd get from the quadratic formula. Okay, I think that is the last example. Now here's a checkpoint from the one book, so give this one a try using complete the square. And then here's an example 5 from the other book. Let's just do this as a practice problem also. So try these two problems, pause the video, and then start them back up and see if you got the answers right. Okay, first one, let's divide by 2. X squared plus 3/2 x. And then we divide this by 2. That'll be a minus 2. Let's move it to the other side where it becomes a plus 2. All right, come up with our binomial. Bring down the x and the plus. Here we could cut our numerator in half, but that would be 1.5 halves. That's not very nice. So let's double our denominator in this one. Double that denominator to a 4. X plus 3/4 quantity squared. Remember now we come down here, we half it. When we're bouncing back up, we're going to square it. Numerator squared is a 9. Denominator squared is a 16. So on this other side, if we add 9/16 there, we're going to add 9/16 there. And I guess, let's see. 2 plus 9/16, that is just 2 and 9/16. Let's make this into a one fraction here. So we multiply the 2 and the 16, and that gives us 32. And we add the 9, and that gives us 41. 41/16. Ooh, yeah, and this one is going to work out nice. Good thing we did that. All right, we're ready now to square root both sides. So on the left, when we take the radical, the square disappears, and we're just left with x plus the fraction. On this side, when we root the numerator, it's just going to be a plus or minus root 41. But in the denominator, when we root that, it will be a 4. All right. And just like in the last one, we have a common denominator. In this one, we have a plus 3/4. So we are going to minus 3/4 from both sides. And then we could just put in our plus minus the root of 41. And that looks like a good answer. Okay, the last one here. Again, leading coefficient is not a 1, so we're going to divide by 3. Oops. So this is going to be 4/3 x. And then this will be a minus 5/3, but we're going to add that to both sides. So over here it's a plus 5/3. Let's figure out our binomial, bring down the x and the minus. Here, our numerator is even, so we can just chop that in half. 2/3. X minus 2/3 quantity squared. And we cut it in half when we bring it down, but we square it when we bounce back up. Numerator squared over denominator squared. So also over here, we're going to add 4/9. Let's see, let's get a common denominator over here. We'd have to multiply our denominator by 3 to get it a 9. Multiply the numerator by 3 and it's a 15. So this becomes what? 19/9. 19/9. And now we're ready to root both sides. Left becomes x minus 2/3. On the other side, our numerator we can't do much with. We'll leave it as plus minus root 19. But down in the denominator, when we square root that, we get the same 3 we have on the left side. So this answer will combine nice into our final answer. Whoa. Oh, dropped 3. There it is. So over here it's a minus. When we bring it over, we're going to add it. So now it'll be 2/3 plus or minus root 19 thirds. So let's make it one pretty fraction. 2 plus or minus our root of 19 all over 3. And that's our last slide. Look for the assignment on the class webpage.